morning, good afternoon to our audience. It's an absolute pleasure to have here with me Oliver. Oliver is the CEO of Impossible Metals. Oliver, thank you for being here with us today. Please introduce yourself and tell us a little bit about what you guys do.
Yeah, thank you for the opportunity. I'm Oliver Gunasekara, CEO and co-founder of Impossible Metals. We build underwater robots to mine the ocean in a way that preserves the marine habitat.
Absolutely incredible. Very exciting to have you here with us and hear all about it. You use robotics to mine the sea. Tell me, how does that work? Is there a particular model that you use?
Yeah, so we've actually invented brand new technology. So it's a new underwater robot that we've designed ourselves. It's designed to go up to 6 kilometers or about 4 miles deep. And it's a fully autonomous underwater vehicle. So it
Mhm.
has a battery and it has its own propulsion. It has robotic arms. And this vehicle is designed to dive to the deep ocean and pick up these potato-sized rocks, which are rich in critical metals. And then the vehicle fills its payload, brings them to the support ship, and then repeats. And ultimately, we would use hundreds of these robots operating concurrently. So it's a mining operation, but actually getting rocks from the deep seabed instead of getting them from land.
Robotic arms that pick up on the ground floor these potato-sized objects that are full of minerals. So tell me, talk to me a little bit about sustainability. So we're not damaging the ocean floor. How are we promoting this new model of sustainability technology as the enabler of sustainability?
Absolutely. Most mining on land involves either tunneling or big open pits, and ultimately it kind of destroys all of the habitat that is there. One of the beauties of the deep ocean is that the amount of life on the deep ocean is pretty small. We're talking, as I said, 4 to 6 kilometers, 3 to 4 miles deep. There's no sunlight. There is life, but most of it is microscopic. It's single cell organisms, bacteria. Now, occasionally there are sponges, there are corals, there's a species of octopus that actually lays its eggs, but this is pretty rare. And
Mhm.
one of the beauties of our approach is that the rocks we're after, they're called polymetallic. So these are potato-sized rocks that form over millions of years, and they just lie on the seabed floor. So first of all, unlike on land, there's no cutting or blasting or tunneling. We literally have to pick up these rocks off the seabed floor. Bit like a golf driving range where you see all the balls. That's what it kind of looks like.
Mhm.
And the traditional approach, in fact, the approach that was tested 50 years ago, is a dredging tractor. So it's a big mechanical tractor that has tracks that's lowered to the seabed floor, and it sucks up or vacuums up these rocks through a riser pump to the support ship. The problem with that is it destroys all the life that's there. What we decided to do when I created the company about 5 years ago was, could we invent 21st century robotics AI that still collects these rocks, but does it in a way that still preserves the marine habitat? And what we have is a robot that, first of all, doesn't land. So we don't have tracks. We don't actually physically land. We hover about 1 meter or 1 yard above the seabed floor. And then we turn on our lights and we have an array of robotic arms. And we use the cameras and lights and the AI algorithms running on the NVIDIA chip to identify where the rocks are so that we can control an array of arms to pick them. And we look for the larger forms of life. We can't see the microscopic, but we can see anything bigger than, say, a few millimeters. So we can definitely see the octopus, its eggs, a coral, a sponge. And if we see this, we just fly over the top without
Mhm.
disturbing it. And in addition, we don't want to take 100% like the dredging system. We want to take probably only 10%. And so that preserves the habitat, because if we remove 100% of these rocks or nodules, the octopus that lays its eggs, it won't have anywhere to lay the eggs. So if we only remove 10%, there's still plenty of room left for the octopus and the habitat. The arms have picked everything up, They're all stored inside the vehicle. The vehicle has no tether, it's no cable, it's completely battery powered. And what it does is it uses its battery and buoyancy system to float to near the surface, where we have another robot that docks with that robot uh, using cameras. And that then attaches a cable. And then once it's docked, we wheel it into a rail system on the side of the ship, bring it on board, unload the payload, swap out a battery for a new charged battery, do any maintenance, and then we redeploy.
Mhm.
I'll give you a 90-second animation that we have on our YouTube channel, which shows how all of
Absolutely.
this works. Okay, so let me play the video. I think you can see it now, right? Yeah.
I can definitely see it.
We developed the Eureka Collection System. Underwater robots are launched from a ship to the ocean floor, where there are vast fields of rocks called polymetallic nodules that are rich in critical metals. Hovering over the ocean floor, the robot uses camera-based artificial intelligence to control its arms, selectively collecting nodules while minimizing sediment disturbance and avoiding all visible life. The collected nodules are stored on board. A large percentage of nodules remain untouched, preserving habitat and biodiversity. Once the robot is full, it ascends to the surface ship. A smart hook autonomously connects to the robot below the wave-affected zone. A crane lifts it aboard using a rail system. The bottom payload door opens, and the nodules are offloaded onto a conveyor belt to transport the nodules to the storage compartments of the ship. The battery is swapped with a fully recharged pack. If required, the vehicle is moved to the maintenance station, where the arm assembly is autonomously swapped out and other maintenance is performed. The full cycle of collecting nodules repeats approximately every 4 hours. Ships travel between the mining area and the processing plant, with full ships departing and empty ships arriving. The swarm of robots remains at sea collecting. Our highly scalable fleet is designed to reach the high production levels required to meet market demand.
Absolutely incredible. That really does help visualize what it actually looks like and how it looks like on the floor when you're saying these arms that collect and how they're able to come back up and autonomously realign themselves and replace, each of the robots. That's incredible.
Yeah, I'd love to just show you one more picture, which is this is
Yeah.
what we've actually built. So obviously that was an animation, and that's showing what we call Eureka 3, the next version, which is
Oh yeah.
larger. But this is Eureka 2. So this version we built first in 2024. We've been testing and upgrading over the last year or so. And this vehicle, as you can see, it's about the size of a small car. You can see it has 3 arms and it can go 4 miles or 6 kilometers deep. And this exists, and we've tested this off the east coast of Florida in the Atlantic Ocean.
That's enormous too. So that's a real size right there. It's almost two humans of tall. Amazing.
Yeah, and the Eureka 3, which you see in the animation, is about 3 times larger. So it's the size of
Amazing.
a shipping container, each one of those robots.
That's incredible. So it's bigger, it's better. I'd love to ask about that quick. It's quite interesting. There's definitely been a Eureka 1, seems like.
Yep.
You're on Eureka 2, you're going on the third. You use AI capabilities. It's a very elaborate and dynamic process, and you guys are very established. And you started in 2020. Allow me to ask you, where's your formation from? How did this vision start for Impossible Minerals? How did you get into this robotics, AI, deep sea mining industry?
I'm actually new to this industry. I don't have
Incredible.
a robotics, yeah, I don't really have a robotics background or a subsea or a mining, but most of my career has actually been in semiconductors. So I was an early employee at a company called Arm that went on to be quite successful. And since then, I also founded a company called NG Codec, which was doing video compression in the cloud and was acquired by AMD, and they made a 5 nanometer chip, with some of our IP inside. But I sold that company in 2019, and then I got concerned in 2020 with the wildfires. I live in Silicon Valley here in North California, and we had really, really bad wildfires about 5 years ago. And that was the catalyst for me to think that maybe I can do one more startup. I've done a few, and this one should be to really help the energy transition. And
Mhm.
somehow I discovered the older technology, the dredging technology, the nodules. And the more I dug in, the more I could see that this tech had barely changed in 50 years. Like there are patents from the 1960s, and they built the system in 1970s. And yet there's a lot of environmental concerns with that approach, and also the cost. And so that was really the genesis of let's build something better.
You were able to find this industry, and it's very true all around the entire mining industry. A little difficult to adopt new methodologies or novel processes. I'm sure, as you know, deep sea mining has a bad reputation. Could you tell me a little bit about that? Why is it that that reputation is mostly based on outdated technology?
Yeah, I mean, I think even to go further, I would say mining has a bad reputation,
Oh
right?
yeah.
Here in the West, we've outsourced a lot of mining to Africa, to Indonesia, to other places, and it's seen as a dirty, old, destructive industry. But what I think people don't appreciate is that it's a fundamental industry. Like there is no human civilization without mining. And humans
Oh
have
yeah.
been mining for thousands of years. We had the Bronze Age, had the Iron Age. This is all mining. So
Hmm.
um, we need mining because without it, there's no technology, there's no energy, there's no civilization. Frankly, everything you look around, if it wasn't grown, it was mined.
Yes,
So it's
exactly.
it's it's really essential. But mining has a bad reputation, and some of it justifiable because mining kills people, it destroys habitats, it forces people off their land, it releases pollution. But deep sea is a new area. We've mined on the planet, on the land for millennia, but we haven't yet mined in the ocean. But people are
Mm.
concerned if we've done such damage on land, are we now going to do such damage to a pristine area that we haven't gone to? And I understand that. And especially when you look at the older technology, the dredging and riser system, uh, it will have a big impact. Everything in front of the dredging tractor will basically be destroyed, just as it is on land. And these ecosystems take a very, very long time to recover. But it is a fact that there's a lot less life down there. As I said, most of it's microscopic.
Oh yeah.
And with new technology, like the fact that we've invented, if we detect the life, the octopus, its eggs, any other form of larger life, we won't disturb it. And then we'll only remove 10%. And the resource is so big that even removing only 10%, we can still provide huge quantities of material because it's just so big. So, the vehicle still fills its payload. The
Mhm.
Eureka 3 you saw in the animation, it has a 4 metric ton, 4,000 kilogram payload. So that's what it's filling every mission. And whether we take 10%, 20%, 50%, it just changes the amount of time that we mine.
Mhm.
Yeah, I think
Incredible.
that there's a lot of NGOs, very focused, non-government organizations focused on trying to stop deep sea mining. Some of it, I think, is based on the fact that land-based mining companies do not want the competition. We think we can mine at a fraction of the cost and a fraction of the environmental impact and do it a lot quicker. And that's going to be very disruptive to people in Africa or Indonesia, where there may be mining companies there that are not going to be able to survive if a lower cost source comes to market. And so you
Mhm.
can see they want to fight this, and so they can partner with the NGOs like Greenpeace and say, let's stop this.
right now the regulations they are adopting and they're changing to actually allow these like small scale miners in the regions that you just mentioned because most of these large ore bodies have already been mined. Mining is unfortunately not sustainable. We're taking stuff out and not
Yep.
replacing it back into the land, but the processes could be. Deep sea mining is not yet a mature industry. There's rules, norms, standards are still forming. It can be more sustainable than land-based mining. You said you're only retrieving 10% of what you find down there, and that is more than enough to fill your clients' needs. So, let me ask you, who are your clients? What are these minerals that you're selling to, and what is next in business growth for Impossible Metals?
The polymetallic nodules, these potato-sized rocks, they're rich in four metals: nickel, copper, cobalt, manganese. There is also some rare earth elements as well, but
Incredible.
primarily it's those four metals. And those metals are used everywhere.
Yeah,
So, of course, batteries is one market, but AI data centers is another market. Defense
yeah.
is another market. These are just very, very common alloys and metals that are used everywhere. In fact, last year, about $500 billion was spent buying these metals, $500 billion. Copper is the biggest, but still,
Hmm.
these are quite substantial. And that market is expected to double to $1 trillion a year by 2035. And a lot of the energy transition, the move away from fossil fuels, is driving this growth because an electric vehicle needs something like 6 times more metal than a combustion engine, a gas-based vehicle. And
Right.
so, as we decarbonize, as we invest in AI data centers, as more people move from rural areas to urban areas, as we spend more on defense, we're just going to need massive amounts more of these metals. So selling a commodity, which is a metal, means I don't have to worry about a customer. If I want, I can put it on an exchange and sell it that way. What I have to worry about is where am I on the cost curve? Very similar to, say, an oil producer. An oil producer doesn't really worry about if there's a market. What they worry about is what is their cost to produce, because the oil price will fluctuate. And if the costs come down, if you're a high cost producer, you'll be underwater, you'll stop. We want to really focus on being low cost. The other thing I want to say is, you asked about sustainability. Why do I think deep sea mining is far more sustainable than land-based mining? It's pretty simple. With our technology, we preserve the habitat. The AI will detect the octopus, the corals, the sponges, any larger forms of life. And then the microscopic life, which is everywhere, will only take 10%. So 90% of the habitat is still viable. On land, you never maintain the viability of the habitat at the same time you mine. But with new technology, we can. How can that not be more sustainable? The fact that even after we've done the mining, you would barely even know. Only if you had a picture of before and after could you see that 10% has been removed.
Absolutely.
It's really maintaining that habitat. So I think that's one reason. The second reason is sustainability. I think is both environmental and social. People.
Oh
Well, we
yeah.
know for a fact on the deep ocean, when you're hundreds to thousands of miles away from any landmass and 3 to 4 miles deep, no humans live there. Whereas on land, mining often occurs where people live. So there's massive impacts to people. They can be forced off their land. They could have to deal with the pollution that affects all of their fishing. They sometimes are forced to work in the mine. There's child labor. So all of these
Oh
social
yeah.
impacts happen. In the sea, there's going to be no human impacts. Our system is automated, it's robotic, and there's nobody living there.
Is there a particular like region limit? Because we haven't even begun to explore the entire ocean. But where are you currently operating? Is there a desired outcome to expansion? And is there any like no man's land where like hasn't really even been touched in mining in the deep sea?
So about 30% of the planet has been explored, of the oceans of the planet have been explored at high resolution, but that still
Right.
leaves a lot that hasn't. But for mining, we've been exploring for 50 years. And for the last 25 years, we've actually had what's called exploration licenses. This is where a regulatory body grants permission to do research, to study an area, to understand what resources are there and also what the environmental baseline is. And the
Right.
most well-known area is this area between Hawaii and Mexico. It's called the Clarendon-Clipperton Zone. It's over 4.5 million square kilometers. It's a huge area of the sea. And it has currently 16 licensed areas. You can go on a map of the regulator and see the boundaries. Each area is about 75,000 square kilometers, so the size of Portugal.
Right.
And there are 16 of them.
Whole
So
country.
yeah, yeah, and so that's where the mining is likely to happen. We have just applied for our own area, and because this is in international waters, it's areas beyond national jurisdiction, it's outside of 200 nautical miles off the coast, it's regulated by a UN created autonomous organization called the International Seabed Authority. And that organization for the last 30 years has been regulating and issuing exploration licenses for deep sea mining. But to be
Hmm.
clear, no one is yet mining. People have been spending the last 20 plus years preparing, collecting environmental data so that they have the right information they can submit to the regulator to start the mining application. And that's likely to happen. Applications have started to be sent, and I think they will be granted over the next few years.
Oh, that's incredible. So that land is like untouched yet, or in some sense, it's like they haven't begun mining there.
Yeah,
That's incredible.
there's a little bit of
Yeah.
test mining.
Right.
So a number of companies have tested equipment, but that's small scale, less than 10 square kilometers were impacted by the test mining. We will be doing test mining in the German area next
Hmm.
year.
Incredible. Is that testing in the German area? Is that Eureka 3? Talk to me a little bit
Yes.
about your your
Yep.
equipment. Eureka 3 is in production currently, or is it still as a MVP
Eureka 3 is in the build phase right
build
now.
phase?
So,
Yeah.
so Eureka 2 is built, tested, proven. Eureka 3 is now in the design was complete. We've ordered some of the components and we're starting to now build. Over the next year, we will basically build and test Eureka 3.
Amazing. Apart from the size, what are the upgrades from Eureka 3? You know, we were talking about AI, or is the AI that you're doing just in GIS, or is it also in tracking data? You know, what is the full update of Eureka 3? What is it going to be bringing to the table?
It's mainly to do with the size. So it's
The
fundamentally the
size.
same
Yes.
architecture. In fact, we are sharing a lot of the same technology from Eureka 2. It has the same arms, it has the same control electronics, the same graphics GPU, NVIDIA chip. So a lot of that has moved forward. But we go from 3 arms on Eureka 2 to 7 arms. And we
Oh.
go from 100 kilogram payload to 4,000 kilogram payload. We go from a 14 kilowatt hour battery on Eureka 2 to over 200 kilowatt hour on Eureka 3. So it's a substantial upgrade in size. The buoyancy
Substantial.
spheres are larger, etc. But fundamentally the same tech. It's just scaled up.
That's yeah, it's definitely a larger scale and definitely. I'd like to dive a little bit into the AI. Are we just using it for the imaging and the tracking, or are we also using it for some sort of like data architecture or in another way than just the images? Talk to me about your AI and the uses that you're seeing in Impossible Metals.
Yeah, so right now we're using it specifically for computer vision. So we use an
Vision.
open source library called You Only Look Once, YOLO, and we've trained that up to recognize the nodules. And so in real time on the vehicle, it can identify uh, nodules. So it can uh, It can calculate the precise movement of the robotic arm and the claw, the end effector, to pick up the nodules whilst the vehicle is moving forward. It can also detect non-nodules. So anything that is not a nodule, we assume is life. That octopus, its eggs, a coral, sponges, submarine cable, doesn't matter. We just assume it's not its life and we don't disturb it. So all of that is the AI algorithms that run locally. Longer
Incredible.
term, we will be looking to leverage AI in things like preventative maintenance. So, in time, some components will wear out. We will get a lot of data as, say, the motors are being consumed, and we may be able to predict, we'll have the manufacturer mean time between failure, but we may be able to predict with the AI exactly when a motor is getting close to its failure and swap that out. That's a great AI use. Also, managing the swarm of robots, because we won't deploy just one. We'll deploy hundreds in time. We'll start with maybe 15, but scale up to hundreds. Managing that swarm, coordinating, telling which robot to launch at which location, where to be recovered, etc. That's another potential AI application. So
Incredible.
there are many ways where I think AI will get layered more into our system. But what we've actually built and demonstrated today is around the computer vision.
Impossible Metals is its own mining operation. You build your own robotics, you have your own permits, and you're mining it and selling, and you're full mining operation. However, I wanted to dive a little bit into a bit more of this AI because, from our perspective, I'm on the land. I do my mining operations on the land, and we utilize AI to help these even small scale, mid-sized miners to be able to give the correct lineage of data or traceability or governance to be able to present it to potential investors or regulations to get more funding, or decrease operational risk. So I'm curious as to these deep sea mining operations, these standards of reporting or data lineage, is that still present, in the deep sea mining
Yeah.
operations?
So the mining code has quite a lot of requirements for reporting and traceability. So it's important that the regulator that gives you permission to operate, that they can audit you. You have to put out reports about how your operation works. They have the ability to come on site and do inspections. So all of this has to be done. There's also something in the battery world called a battery passport. It kind of started in Europe, and this is the
Battery.
idea of having traceability, so you know where the metal came from and how it got into the battery. And that's something that we'll be supporting, probably with like a blockchain. So for every
Oh yeah.
payload of the robot, you'll be able to see when was it collected from the ocean. You'll potentially be able to see the video imagery, because we'll make that available, the sensor information. So we want to be an open as transparent. Obviously, monitoring in the middle of the ocean at depth is not easy, but we have lots of sensors and cameras, and so we'll open that data and make it available in a website for people to go and see what's happening.
That's very refreshing to hear, Oliver. I love it. I absolutely love the sustainability, the robotics, the AI, just the entire thing. It's really incredible. And if someone wanted to potentially get into contact with you, learn more about you, or just get into any sort of communication or collaboration, what is the best way to reach you or learn more about you, about Impossible Metals?
Yeah, I think our website, impossiblemetals.com, is where we have videos and animations. And in fact, today we just published a 3D model of the Eureka 3. You can actually go and interact with it and rotate it. It's pretty cool. And
Awesome.
the technology, Eureka Collection System. So that's probably the best place. Also, I'm pretty active on LinkedIn. So if people wanted to, message me through LinkedIn, just my name, Oliver Gunasekara. That's another good place to reach out to me. We also have a contact page on the website.
Incredible. Yeah, we're absolutely going to leave the website down below in the comments, your LinkedIn as well. Thank you so much for being here on the show. It's an absolute pleasure. We're definitely going to love to have you on sometime in the future. And thank you so much for hopping on. It's been an absolute pleasure.
Thank you for the opportunity. Really appreciate it.
Yeah, all right, great. And thank you for the audience. We'll see you in the next week. And you have a wonderful day. And thank you all so very much.